A different way of measuring angles, just like if I asked you the temperature outside. If you're in Canada, you'd say 4 degrees. If you're in the States, you'd say 58 degrees. Okay? They mean the same thing, they're just using two different scales in measuring the temperature. Okay? And we know that there's a conversion between the temperature in degrees and the temperature in Fahrenheit. We can convert from one to the other. Today we're going to learn a second way of measuring angle sizes. So again, this is your D12. You can look at this as a quiz if you want to quiz yourself after. But the first thing we're going to do is we're going to talk about the relationship between arc length, the radius, and the number of radians. Okay, so to measure an angle in degrees requires a person to have a protractor, right? We've all worked with a protractor before. But what I want to be able to do by the end of this lesson is to be able to measure an angle with using a string and a ruler, which we're not physically going to do, but you're going to see how we're going to use those materials in order to help us measure. So here's an angle. The angle is AOB. If I ask you the approximate size of that angle, and a lot of times we use Greek letters, this one's theta, to represent angles. If I ask you the approximate size of that angle, what would you say it is? How? 45 degrees. Okay, so you have a general idea of how angles look with degrees because you've been working with degrees through your mathematical career up until this point. Okay, so they do measure it, and I think it works out to be 34, but you get a general idea of how it looks. What I wanted you to be able to do by the end of this course is, maybe you can take that out of the back there. Is look at that and say, okay, that's pi over 4 radians. Good. What you're talking about right now, it's just a different way of measuring angles. So what we do is we took the exact same angle, we didn't change anything, but I put the center of the angle at the center of a circle. And when I do that, that gives me some new measurements. The length between O and B is the radius of the circle, right, which I can measure using a ruler. The arc length between A and B is the distance along the circle. Okay, and I can measure that using a piece of string and then taking that string and measuring it off on a ruler, right? So I can get this distance and I can get it this distance. Pretty straightforward stuff. If I take the arc length and I divide it by the radius, then that answer is going to be the new size of my angle, and it's called the angle in radians instead of degrees. Okay. Now this will do exactly what I just said. It takes the radius, takes the arc length, it measures off the radius, measures off the arc length, takes the arc length, divides it by the radius, takes the actual measurements, divides them out. So the size of that angle is 0.51 radians. Okay? It was 34 degrees, but now it's 0.51 radians. Radians are a different way of measuring angles. Okay? That's all they are. Okay? So if I want to measure that angle, I would just take the arc length and I divide it by the radius, and that's also 0.51. I don't know if you noticed, the only difference between the last example and this example, the angle didn't change. The only thing that changed was the size of the circle. Okay, so if you take the radius and divide it, the arc length divided by the radius, you're going to get the same ratio. Okay, the ratio between the arc length and the radius is called radians. Okay, so let's figure out the relationship between the number of radians and the number of degrees in a circle. So we'll go up to here. And we're going to be working on radians. So remember that radians are just a new way of measuring angles. Okay, the number of radians is equal to the arc length divided by the radius. So whatever that answer is the size of your angle in radians. So let's figure out what the relationship between degrees and radians are, because that'll help us to convert from one to the other. And ultimately, that's what we want to be able to do by the end of this lesson. So if I have a circle, that distance there, I'm going to call the radius, the distance from the center of the circle out to the edge of the circle. Okay, so if I go around the circle, so in standard position. If I go all the way around, how many degrees did I go if I go completely around the circle? 360. Okay, so we know there's 360 degrees in a circle. What I want to do is I want to figure out the number of radians in a circle. Okay? So I'm going to do the exact same thing. I'm going to start here. I'm going to go all the way around the circle. So the number of radians that I've gone is the arc length. So for me to go all the way around the circle, what would the arc length of that be? Right. And what's the formula for the circumference in terms of the radius? How do you figure out the circumference if you know the radius? What is the formula? Does anybody remember that? Remember? Just 2 pi r. The square difference is the area. Okay, so the arc length is 2 pi r divided by the radius, and I simplify that. What would the simplify down to? Okay. 2 pi. So what we just learned is that there are exactly 2 pi radians in a complete rotation. Okay. What is the approximate number of radians, do you think? How would you figure that out? Yeah. What did you do there? Yeah, exactly. So pi is 3.14, multiply it by 2. So it's approximately 6.28 radians in a complete rotation. Okay. But let's come up with the relationship between degrees and radians. So Kyle told me that there's 300, I think it was Kyle, there's 360 degrees in a circle. And now we know there are 2 pi radians in a circle. Now, usually when we deal with radians, we don't write any units. So I'm just going to write down in brackets that 2 pi radians is the exact same angle size as 360 degrees. But since they're both divisible by 2, we can simplify it by saying 180 degrees is equal to pi radians. So what we want to be able to do is to use that relationship to convert from degrees to radians and from radians to degrees. So to convert from, first of all, from radians to degrees, and second of all, from degrees to radians. The relationship is 180 is equal to pi radians. So if I want to go from radians to degrees, I want my radians to cancel out. So I'm going to multiply by 180 degrees over pi. And if I want to go from degrees to radians, I want my degrees to cancel out. So I'm going to multiply by pi over 180 degrees. Those are my conversion factors. So let's just practice doing a couple conversions. Convert to radians. So 90 degrees. So we're all familiar with what a 90-degree angle looks like. And I want to figure out what 90 degrees is in radians. So to convert, remember the relationship is 180 degrees is equal to pi radians. So I want to end up with radians. So I'm going to multiply by pi over 180. Because remember, you want the degrees to cancel out. So now I get 90 degrees times pi over 180 degrees. Again, the units would cross out, leaving me with 90 over 180. 90 goes into 90 once, goes into 180 twice. So pi over 2 radians is the exact same thing as 90 degrees. And again, if I wanted the approximate value, which we never really do, but we do cover it in your guide, so I want to cover it, you would just take pi and divide it by 2. So whatever that figure is, what was that, like 1.7 something? So when we're working with radians, the hard part for people and the hard part for these next couple of units is going to be not the grade 12 radian stuff, it's fractions. That's what everybody struggles with, is the fraction part. Okay? So get to know your calculator. So if I wanted to change 135 degrees into radians, right? What I would do is multiply it by the conversion factor. So essentially it boils down to simplifying the fraction 135 pi over 180. Okay? So you know the pi is not going to go anywhere. So leave that out when you put it in your calculator. Just put 135 over 180 and hit equals. It'll simplify it for you automatically. Okay? Get to know your fraction button. Right? If you don't know how to use it, ask them. If you don't know where it is, ask them to show you how to do it. So what does that simplify down to? Yeah. Yeah, exactly. So that's the exact value, the approximate value. So the approximate number of radians would be 3 times pi divided by 4, which would be, can someone do that for me? Yeah, okay. Thank you. Okay. But again, remember in this course we're going to be working with the exact values. Okay. So the most important thing is to be able to convert from degrees to radians and also from radians to degrees. So let's convert to degrees. So 7 pi over 6. Okay. So again, you look at that, you have really no idea, unless you're really picking up on this, what that angle size looks like. Okay. I have a general idea, but again, I've been doing mathematics for 42 years, right? So 7 pi over 6, multiply it by the conversion factor. And again, this time, right, you want to end up with degrees, so you're going to multiply it by 180 degrees over pi. You want your answer to end up in degrees. Okay, so the relationship's always 180 and pi, just depending on which one you want to divide through. Pi divided by pi is 1. 6 goes into 6 once, goes into 180 30 times. 7 times 30 is 210 degrees. But again, you can just do this on your calculator, right? 7 times 180 divided by 6, and you get 2. Okay. Negative 11 pi over 12 radians. We want to figure out how many degrees that is. So before we even get into the conversion of it, how does a negative angle make sense? Does anybody know what a negative angle is? Okay, when we measure angles, I'm going to go back to here. When we measure angles, you always put, so your arm is what's called your terminal arm, and then you always put it on the x-axis and you go counterclockwise. Okay? If you're doing a negative angle, you put it on the x-axis and you go clockwise, and that's a negative angle. So this way is positive angles, this way is negative angles. Okay, so we multiply it by our conversion factor. So the pi's would cancel out. Negative 11 times 180 divided by 12. Someone tell me what that is? Rebecca? So 11 pi over 12 is the same thing as 165 degrees because it's negative. Okay. So the most important thing from this lesson is understanding that radians is just a different way of measuring an angle size. Okay. So we're familiar with measuring angles in degrees. So they have those little ticks, right? You just count the number of little ticks around. But in radians, you're taking the arc length, whatever is produced, and you're dividing it by the radius to get the number of radians. So if I go back to this, I just wanted to make you aware of what's in here. So a lot of the stuff I've already said. So the ratio between the arc length and the radius is the number of radians. Radians is another method for representing angles. Radians don't have any units. Okay. And the last example, what was that? we would write that. Now, I don't know who wrote this. I didn't write this. Somebody wrote this up. But I found it somewhere. I thought it was pretty cool. They say that radians have no units, and then they throw in this RAD here. Okay, you don't have to do that. Radians always don't have any units. Here's the formula for finding the number of radians in a angle size. It's the arc length produced by the angle divided by the radius. That's all radians are. And then there's some examples you can work through. So to find the number of radians in this angle, you would take the arc length, you divide it by radius, straightforward stuff. Okay. And there's some more you can work through. And you can work through that for your leisure. This one right here is the converting part. Right here, so it talks about what I talked about, how the number of radians is the arc length, which Kyle gave me was the circumference, and then simplifying it. This is all stuff we've done, and it simplifies to that, and then it says, therefore, 360 degrees is equal to 5. It'll be done now. Okay? So you can convert, and then there's a quiz. If you want to do the quiz, you can answer that, and then there's how to do it on your calculator. Okay, so this is all there for you on D2L. If you want to play with it, great. If you understand the fact that radians are another way of measuring an angle, and you're able to convert from radians to degrees and from degrees to radians, that's all you really need to know for your lesson. Okay? Any questions? Okay, so I'm going to save this. Again, right, tomorrow's the last day for work submission.